Generative media models suffer from a structural flaw. They are inherently probabilistic. This leads to severe visual and temporal drift. When attempting to render a complex narrative, this frame-by-frame variance breaks spatial coherence and renders character continuity impossible across long durations. Overcoming this drift requires moving away from manual media assembly in favor of a localized programmatic architecture. By wrapping unpredictable generative outputs inside a deterministic software bounding box, we force the AI to operate within a rigid production pipeline. Addressing these limitations requires a transition from prompt-based workflows toward the development of rigid engineering frameworks. The Maison Esthétique Studio OS is an autonomous studio-in-a-box pipeline designed to enforce mathematical constraints on media generation. This schematic outlines the architecture. The pipeline relies on three specific mechanisms: optical flow evaluation, rigid truth tables, and mathematical backtiming. At the end of this processing chain, raw screenplay markup and JSON data are converted directly into native OpenTimeline I/O manifests. The OpenTimeline I/O format provides the necessary translation layer between programmatic data and standard nonlinear editing frameworks. We will now break down this architecture from first principles, moving from text ingestion to final timeline export. The automated pipeline begins at the Layer 1 ingestion phase. The system monitors the awaiting script.json file to detect incoming scripts and storyboard metadata in real time. Once data is detected, Layers 2 and 3 act as secure agentic gateways, managed through the systemconfig.py module. These gateways parse the JSON data and transmit structured prompts to external AI endpoints for rendering. To maintain stability during long compilation tasks, these layers utilize automated retry backoffs if an API connection is interrupted. Establishing a fault-tolerant ingestion layer is the prerequisite for all downstream autonomous rendering. Moving beyond text, the system integrates physical hardware telemetry, utilizing data from the Volts and Ventures e-bike project. The stabilization.py submodule receives telemetry from the Gugoi's GT20 platform's EN06 controller and 748 watt-hour battery pack. This mapping grid shows the Farnbach optical flow algorithm calculating pixel displacement across a 360-degree projection. The algorithm separates the intentional panning of the camera from the unwanted high-frequency vibrations caused by the e-bike chassis. This telemetry data is then used to dynamically reframe and stabilize the final video output without manual intervention. Physical hardware constraints are used here to actively dictate software rendering parameters. Spatial and identity coherence across generated clips is managed via shotclassifier.py and SQLite state tracking. The tandem continuity engine audits all generated plates against a strict set of character and environmental rules. This Boolean matrix illustrates the 5-point truth table evaluator utilized during the production of The Ballad of the Black Duster. The system enforces binary checks on 5 anchors: character identity, the alkali dusted coat, chiaroscuro lighting, the Colt revolver prop, and 2.39:1 framing. To prevent temporal sliding in action sequences, the system applies biomechanical choreography mapping. Action is deconstructed into precise phase intervals, 0.17 second stance and 1 second draw, forcing exact mechanical timing. By forcing generation through these truth tables and phase intervals, the pipeline eliminates visual hallucinations. Layers 4 and 5 are the convergence point where media assets are finally aligned. The V2V.py module operates an audio-first pipeline to ensure timing precision. The system integrates custom 11 Labs and Qwen3 TTS checkpoints alongside spatial environment modeling. This diagram demonstrates the backtiming constraint that forces video generation to conform to exact audio durations. The pipeline determines the frame budget for the AI generator using a specific formula. Total frames equal the rounded product of time and frames per second plus 1. This calculation is mandatory to prevent audio-video desynchronization in an automated pipeline. In an autonomous system, time-based alignment requires that audio serves as the master timeline. In the final sequence, the system routes aligned assets to local FFmpeg binary processes. FFmpeg compiles video plates, audio stems, and metadata into a unified directory. The pipeline then generates the .otio OpenTimeline IO manifest from these compiled assets. This manifest file unpacks directly into DaVinci Resolve as a multi-track timeline, ready for immediate rendering. This completes the cycle, transforming a raw JSON script into a complex editing structure without manual assembly. The Studio OS architecture encapsulates unpredictable generative models within strict software engineering principles. This stability is achieved through the combination of SQLite state tracking, truth tables, and strict time-based math. This structured approach provides the control that is missing from basic, manual generative AI prompting. Ultimately, the advancement of computational media requires autonomous pipeline frameworks that enforce absolute programmatic control over generative variants. Manual media assembly is transitioning into a process of programmatic compilation.